All right, welcome back, students. We have 1.3 particulate diagrams today. All right, so our particulate diagrams, this is probably going to be completely new for all of you, but our particulate diagrams are ones that show, like if we could see it on a molecular level, this is what we would see. So we are showing what a substance looks like on the molecular level. On the molecular level. Now, like I said, this is probably going to be new for us, but I don't think it's that hard. We just have something new, so there's that. All right, so our rules for drawing particulate diagram. Our particles must be distinct and countable. So what we can do that is we have to use different shapes and colors. So you have a whole bunch of colors with you. You could also just use different shapes, a square, a circle, a triangle, all right? A star if you need to, all right? And so different substances need to have different shapes and colors. If we have more mass, we have more particles. All right, but we're going to draw them all in this cute little box, if you will. So here we go. Let's look at our first example because kind of the best way to do this is kind of via examples. So if we look at our first example, we have a solid element. So what's it mean to be solid? Remember, a solid is something that is rigid in shape, right? It has a distinct volume and a distinct shape. So it's not like we can just float it all over the place. So it's going to take up its own little space. An element, we said, has all the same atoms, right? All the same atoms. All right, and we're going to say a distinct shape here. All right, so let's go ahead and break that down. So my favorite shape right now, let's go square right here. All right, so we know that we have an element and we're going to go with a square to represent that element, and the squares should all be the same because we have the same atoms because it's an element. All right, yes, some of my squares are not quite the same, right? That last one looks a little rough. But for the most part, they are the same shape, right? Now let's kind of shift gears a little bit. This time we have a solid compound. I'm going to shift colors here. Solid compound. So it's still going to have that distinct shape, right? Still think distinct shape, but now a compound, it's going to be the same ratio, right? We talked about that. Same ratio of atoms. Okay, so what we need to do is have a ratio of atoms this time. So let's say we're going to do a triangle and a circle. And we'll do a couple of those, still keeping that distinct shape, right? It's not taking the shape of the container. We have the same ratio of atoms. Each of them are a triangle and a circle. Okay, let's take it a little further. All right, now our liquids, all right, our liquids mean they're going to take the shape of a container. Like when I pour my water or my coffee into something else, it takes the shape of the container, right? It doesn't just stay rigid. Whereas if I dropped a rock in a container, the rock would stay a rock and looking in its shape. All right, so a liquid element, so we have all the same atoms, but we're going to have a liquid element. That means it's going to take the shape of the container. So let's do boxes kind of taking the shape of the container a little bit. All right. Notice how it's sitting on the bottom because most of the time liquids are more dense than air. So it's sitting on the bottom, right? And it's taking the shape of the container. Okay. Now, if we want to mix a liquid mixture, so that was an element. A mixture just means we have a whole bunch of stuff going on in it. So we can just mix in a whole bunch of different shapes. So let's say we do a couple of squares because it's a mixture. Then let's change colors and go, how about a couple of circles? Because why not, right? All right, and then how about some green triangles just to finish this out? All right, notice how it's taking the shape of the container. All right, and it's definitely a mixture. There's no rhyme or reason for what we did there. Okay, awesome. Let's finish this out. So we have a gas is our next one. So gases are going to take up the entire container. So we're just going to spread those babies out throughout. And it doesn't say if we want it to be an element or a compound, so we can just mix in whatever we want. So let's do a circle, triangle, maybe a box. Ooh, how about a star? Dollar sign? We've got it all mixed up. That's our gas. Okay, and this one would be a homogeneous mixture gas, right? Because we have all different stuff. Okay, and finishing it up, what about a homogeneous mixture? This means it's just got to look the same. So it's all got to be a solid, it's all going to be a liquid, or it's all going to be a gas. Well, we just drew a homogeneous gas, so let's draw a homogeneous solid. We can do that. So change colors here, get back to red. Let's go circle, 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 and then a square. All right, cool. There you go. There's our homogeneous mixture that is a solid. Questions there? All right, see you on the next one.